Okay, welcome everybody in this fifth webinar of the Titan project, which we specifically organize for our Stakeholder Board. We have three eminent speakers today, and I look very much forward to their presentations. First, I will give a short introduction myself. So the Titan project is about enabling transparency in the food supply chain via the implementation of digital technologies mainly, but we also work on DNA-based technologies, as you will hear from Marta, to boost health, sustainability, and safety of products, processes, and diets. The program for today is first we have a presentation about food safety and transparency through cutting-edge DNA-based analysis methods by Marta Prado. This will be followed by a presentation on transparency and redefining stakeholder roles in the digital age of agri-food supply chain networks. And then Joe Livingston will present on developing the SUS Health Index. Every presenter has 20 minutes, and then after the presentations, we will have a Q&A session. So please listen carefully to the presenters and make notes, and please think of some questions you can ask at the end of the presentations. In the Titan project, we are now almost halfway. We are active now, I think, 21 months with the project. Every week, we launch the Titan Weekly via LinkedIn every Tuesday around noon. This contains about 20 news items that are related to the topics we are active in. So informing the consumer, supply chain sustainability, and also the implementation of new technologies. But also we give webinars that are planned or upcoming. So it's very interesting. So please check out our LinkedIn account every Tuesday and take a look at the Titan Weekly. We also bring out a newsletter, and the sixth newsletter was finalized and sent around last week, which contains a lot of interesting information. For instance, that Titan partners have produced 11 practice abstracts, which they in which they, in a condensed way, describe some methods. Very interesting material that is available on the website, and that is also promoted on LinkedIn. Then we were with a significant number of partners were present at the Food for Future Expo in Bilbao, and here you see our booth. I think there were 16 of the Titan partners, associated partners, were present, so that was quite impressive. And then one special news item about Titan Total Control, because they have won their 50th award. So we are really happy to have such a strong partner in the Titan project. And then linked to the newsletter, we always share a PDF with relevant scientific publications and policy reports. Please check it out. It's a long list, and there might be relevant materials for you in there. For example, here you see the report from the GRC on food fraud, and also a report on fighting fraudulent practices from the EU. And here you see two reports, one from Farm Force, one from Meridia on first mile traceability, and the one from Meridia is about deforestation. And this is a nice bridge to the next slide. We will have another webinar on the 19th of June, where we will have three, let's say, new developments, new tools that we think are really hot at this moment. Esther and David from ASTI will present a new tool called Enviro Digital. It is based on the Enviro score, but it helps companies to make their warehousing, the purchasing of ingredients, and maybe also the labeling of their products digital, which can be a really good improvement. Then Kees van der Elst will present the EMIS platform, a digital platform developed by Q Assurance. It took them 20 years to develop this platform, and now the customers, they fly in, and this helps companies that struggle with audits to digitalize the auditing and everything around this. And then last but not least, Meridia will present a Verify tool. And this is a very important tool with data verification in line with the EU deforestation regulation, and they were selected because they received more than €5 million funding very recently. So this is upcoming. Today we have this program, and I stop sharing and I'll give the floor to Marta Prado, and she will speak on behalf of the University de Santiago de Compostela in Galicia, Spain, but also a little bit on behalf of INL.
Thank you very much, Edward. Thanks a lot for the introduction and the presentation. So, as Edward was mentioning, I'm currently at the University of Santiago de Compostela, but much of the work that will be presented has been done at the INL, which is the International Iberian Nanotechnology Laboratory, and we are still collaborating in the framework of the Titan project. So my presentation is food safety and transparency through cutting-edge DNA-based analysis methods. Just a small introduction about myself. I'm a food scientist by degree, and I have been working on the GRC between 2005 and 2010. And from 2010 and 2023, I have been working at the INL, the International Iberian Nanotechnology Laboratory, where I led the Food Quality and Safety Research Group. And since October 2023, I'm a Senior Distinguished Researcher at the University of Santiago de Compostela. Just to give you a background why we are talking about INL and the University of Santiago de Compostela. So this is the schema of the presentation. I will start talking a little bit about authenticity and traceability. Then I will go to miniaturization of analysis. And then I will give you as well some examples related with one authenticity, an olive oil value chain, and some other details about the work that is being done on the Titan project. So what is traceability and what is authenticity? They are normally mentioned together, let's say, and sometimes they are even confused. But there are some difference. No, traceability is when we can trace back a product, in this case a food product, from the farmer to the consumer, where we have all the path of this product. We have all this information. And authenticity is basically, to say it in a simple way, when what is written in a label, in a food label, what is indicated in the marketing is actually true, right? So it corresponds to what is inside the packaging. So there are different types of let's say adulteration or changes on authenticity of a food product. No, an authentic product is defined as a food product where there is a match between the actual food product characteristic and the corresponding food product claims, when the food product actually is what the claim says that it is. This is a definition from SEN. But sometimes, depending how this non-authenticity was produced, is considered in a different way. For example, food fraud is considered when it is economically driven, so it's intentional, because the people that is doing that has some economical motivation. There are other types, such as ideological driven, when there is a case of intentional adulteration for some specific intention of harm the population, for example. And then there are the cases where there is accidental adulteration of a product that could be related to food quality, when the quality is not the same, or even to food safety, when it can affect the health of the consumers. So as I was mentioning at the beginning, we are working on the miniaturization of analysis, because the main objective is to be able to bring the lab to the field, right? So to have things as simple to use as a pregnancy test or as this COVID test that we had, unfortunately, during the last years, no, that allow us to make a very simple analysis to have a positive or negative results. There are a lot of things that need to be analyzed, but not all of the things that we need to analyze are currently miniaturized or allow connectivity to make a good use of all the data that we can take from the food value chain. There are a lot of research efforts that are being directed towards microfabrication that contribute to have these small devices that allow us to perform decentralized analysis. The miniaturization of this type of more sophisticated or advanced sensing will contribute for sure to a more reliable and safe food value chain, as well as the food authenticity, right? But how can we include hamburger inside a miniaturized chip? No, this is not an easy task if we think all the things that we need to analyze. So how do we work? We work using a modular approach, in this case for DNA analysis, where we work in each of the modules of the analysis independently in order to make sure that we have the best possible results at the best possible device. So for example, just a few examples. So if we think about DNA purification, we are combining microscale solid-phase extraction with microfluidics in order to have enough and with high quality DNA from any type of food product. We are also working on isothermal DNA amplification in order to perform DNA amplification at constant temperature, which allow us to miniaturize the devices on which we are working with. Some examples from previous projects. We had a project where we miniaturized the analysis of Douro and Porto wine. As you might know, geographical denomination of origin of wines requests that the wine is produced with a specific grape variety from a specific region. But this is not so straightforward. So in this case, what we did, it was to use a graphene-fed sensor in which we mobilize a DNA capture probe that allow us to identify the corresponding DNA, the grape variety that we could have in the wine. And this, we work in the DNA extraction, in a DNA amplification for enrichment of the region where we want to detect DNA probes, and of course in the detection based on graphite sensors. And now coming back to Titan. So one of the use cases in which we are working is olive oil use case, as we call it. Just to mention that olive oil is in the top 10 of food products at the highest risk of food fraud. There are different types of adulterations of olive oil, but one of the most challenging to analyze is the misrepresentation of the origin, the cultivar, or the category. And DNA analysis can be of great help for detection of adulteration and cultivar identification, but it is challenging to extract the DNA and to obtain enough DNA for DNA analysis. At the same time, there is a high interest from both producers to add value to high quality local products. Also, there is an interest by consumers to buy local, sustainable, and authentic products. But on the other side, it's really difficult, and we need to make this technology accessible. So currently, it's been, this type of analysis is being done in a laboratory, and it's quite complex analysis, but we need to bring this to the field. We need to bring this type of analysis to producers, to the different stakeholders in the food value chain. So we have done that. We had first obtained enough DNA from olive oil, which, as you can imagine, has a very minute content of DNA, since we are extracting the oil from seeds, and normally we are getting rid of any rest of vegetal material. So it is very important that this first step of DNA extraction and purification in order to be able to analyze this product, right? So we, in this case, we develop a miniaturized device based on microscale solid phase extraction and microfluidics that allow us to obtain a really high concentration of DNA from this type of products. So we got 3 times higher for spike extra virgin olive oil and 6 times higher for non-spike extra virgin olive oil. Meaning that with a spike is that we were adding DNA in order to have something for sure that we could quantify. So we test both things. We have developed other type of miniaturized devices based on microscale solid phase extraction and microfluidics, such as this device fabricated in PDMA. So it was a disposable device where we obtain DNA from water in this case, in order to be able to detect the presence of invasive species in water basins, river basins, sorry. And coming back to the olive oil use case, we have also worked on the miniaturization of the analysis, the DNA analysis, no, in order to be able to fully identify the presence of varieties. So in a previous study, what we did, it was to evaluate which markers, which DNA markers, which might seem simple, but it's not actually, which type of markers we could use that allow us to miniaturize. Because as I was mentioning before, normally this type of analysis are being performed in lab with sophisticated equipment. So we test different type of markers, and we also develop a miniaturized device and a cartridge in order to amplify this. In the Titan project, we are currently working with varieties from Cyprus and from Turkey. We have identified previously these markers, so now what we are doing is obtaining the DNA sequence from these genetic regions that we found of interest, because they have a small variation in the DNA sequence. So we obtain a good number of samples from these varieties. We did a conventional DNA extraction. We did a DNA amplification of the region that we wanted to sequence, and we sequenced these genes in order to identify SNPs, as it's called, is a small difference between different varieties, and in order to develop these specific methods in which we are working on to be able to differentiate this from other varieties, right? We are working on the integration of these methods as well on miniaturized platforms that are based on a fixed, let's say, electronic device where we have all the thermal control and the fluidic control, and then disposable cartridges that can be introduced in this device and where we will perform this analysis to be able to identify. And this is being done in collaboration with other partners because we are also linking our devices with the blockchain in collaboration with the Open Food Chain. We are evaluating as well the specificity and the sensitivity of the reliability, in one word, of the methods with the help of, as well as focus. Then in the Titan project, we are applying very similar approach for the specific detection of allergenic ingredients in food products. So there are certain ingredients that can cause allergic reactions in consumers that are suffering for this condition. So it's very important for the food industry to be able to have a better control of their processes, and artificial intelligence in this case can help us to predict and to avoid those allergens, reducing the number of analyses. In this specific case, we are working on as well in a miniaturized device, but in this case, for the detection of some allergenic ingredients, they are particularly challenging for the bakery-related food industry, such as sesame, mustard, or soja. So they are unintentionally appearing in this type of products. And the food industry wants to make sure that they are not in the raw materials, that all the food production is after the cleaning is completely safe of this. So we are we identify some DNA markers. Here is mentioned Maturase K gene, but also we are working with ITS gene. That is a different genes that have a number of advantages among other genes, such as being maybe highly repetitive in some cases, so we can have better sensitivity, and also that the sequence, there are differences between the sequence that allow us to differentiate this type of products. And we are working on isothermal amplification combined with colorimetric detection in order to be able to have something that could be miniaturized, that could be easy to use, and that could be integrated and could be used in the different points of the food value chains. Here is an schematic representation of the allergenic ingredient detection based on these miniaturized devices. We have a multi-position valve that can connect the different reagents for analysis. We have a disposable cartridge inside of which we have all the reagents that we need for this specific amplification and detection of these allergenic ingredients. And just to finalize, some final consideration is that micro and nano fabrication are key technologies in the development of advanced analytical devices. And this modular approach has proven to enable the development of reliable analytical solutions. And also that all this miniaturization, connectivity, and data transmissions are key for the future to take full advantage of those devices and provide reliable traceability, authenticity, and as well also safety. And just to thank also my team from INL. Some of them are here, and also our collaborators, the Titan project, and our previous projects as well that lead us to this work. Thank you very much. Thanks a lot. If you want to reach out, please find there my contact. Thank you very much.
Okay, thank you, Marta, for a really nice, interesting presentation. I give now the floor to Verena Otter from Wageningen University to present on her work. And please keep the questions for the end.
Verena, you're on mute.
Can you see my screen well?
Yes, we can. Thank you.
In presenter mode or in normal mode?
No, now it's in presenter mode. Thank you.
Okay. So only the slide, right?
Yes.
Okay. Yeah. Thank you very much for providing me the opportunity to present our work in this workshop. My name is Verena Otter, and I'm working indeed at Wageningen University. And I'm happy to present today our outcomes from work package 2 of the Titan project. And basically, it's a part of our work in that work package. I will explain it to you in some minutes. So that piece is actually looking into transparency and redefining stakeholder roles in the digital age of agri-food supply chain networks. And I'm not working alone. I've not been working alone on those contents. So the team next to myself is Douglas Robinson, who worked as a postdoctoral researcher in the project during the first phase. and Santiago, who has been working as a researcher as well and was largely involved in conducting the focus group discussions. My own focus is on innovation and organization in supply chain networks. This is why the project is actually quite in the core of my research. Especially when we are looking at the first task, we have actually planned that, that research around the net chain approach, so an approach that is on complex relationships in supply chain networks. And we have extended for that research this approach by stakeholder management elements. And we put particular focus on the transparency in the relationship between the different actors. In addition to our conceptualization that we developed as a background, we have conducted quite a lot of interviews with pilot companies and some focus group discussions using the net mapping technique to identify the relationships between the stakeholders. And the outcomes that I will present to you are the ones from the deliverable 2.1, which we submitted last fall. So what is the basic idea to taking a more complex supply chain network view from a multi-stakeholder with a multi-stakeholder perspective? So what we know from the literature so far is that supply chain networks, especially in agri-food, are quite complex. They are very dynamic, and they have different. They are on different scales. So spatiality also plays quite a role if we compare, for instance, regional and global chains with each other. So what they have basically in common is that you can find quite a lot of so-called primary stakeholders in the chain, which are connected vertically and horizontally. So vertically, you have, for instance, the primary producers that deliver to collectors and processors, which further deliver in a vertical relationship to manufacturers, etc. But on the other hand, they can also have a horizontal relationship to each other because they are collaborating, for instance, with competitors for shared benefits. That can happen on the product level, but it can also happen, of course, on the information and data level. And in between, you have quite a lot of intermediaries like traders and transporters that potentially only own the product without adding more value to it and forward it to other primary stakeholders. So basically, this is the general idea of a complex supply chain network view. And what we consider stakeholders at the moment, we are using basically in that conceptual setting stakeholders and also as a synonym for actors. So what we see basically is a complex network of actors, and the relationships in between can be to different degrees transparent. So we have established basically the definition by Gert-Jan Hofstede on transparency in net chains, which means that transparency is the extent to which all stakeholders in those net chains have a shared understanding of and access to the product-related information that they request without any loss, noise, delay, and distortion. And that can be different types of information and data. It can be on tracking and tracing, like history transparency. It can be on the operations of a company, or it can even be strategic information that is quite sensitive. We have actually conceptualized beyond only the primary stakeholders, which I have just explained, because around that complex network of quite a lot of vertical and horizontal relationships, we also find lateral relationships to so-called secondary stakeholders. And different to the primary ones, which have an economic interest, they have an influence or are influenced by the organization, but are not directly transacting products or services with them. And these can be, for instance, policymakers, NGOs, laboratories, advisory services, etc., or even media and social media. So this is actually what we know from the literature, and we wanted to find out more how in the digital age basically the roles or which primary and secondary stakeholders exist now that we are having more digital innovations, more information and data is shared. So are these still the same primary and secondary stakeholders, or do we see more new stakeholders in those networks? And are their roles and interests potentially changing with an influence on the organizational structure of these networks? So what we basically did is that we have decided to first conduct 12 expert interviews with chief operating officers, chief executive officers, and founders of different technology providers that are active in the EU agri-food sector, and provide different types of digital technologies and services. And then we have conducted in total 8 focus group discussions, and I will present the results of 5 of those focus group discussions later. And we used the net mapping technique to actually also visualize the complexity of the system. And we have actually chosen for main food categories from fruits and vegetables, dairy, fish, and meat. Then we processed and analyzed the qualitative data that we have collected using the software Atlas TI and structured content analysis, and we interpreted the results. So in deliverable 2.1, this is a quick or brief overview of all the technology providers that we have interviewed, and you can see that the primary offerings differ across different digital technologies and solutions. We have also different sizes, although most of them are small enterprises, and which you can see also in the FTE that they have and the turnover, the range of turnover that they show. They are actually, these 12 providers are located in 8 different EU countries, and they have different legal forms, including private limited liability companies, or respective equivalents that can be considered. So these are basically the pilot interviews that we have conducted. And in summary, we can see that already the technology providers have shown quite an overview of primary and secondary stakeholders, which we summarize in 2 different figures. I will explain the difference of the figures in a minute, but in a nutshell, we can see that the primary net chain stakeholders that they consider important are on the production, processing, distribution, and retail stages. There was a note made on a 5th stage, which mostly applies to international supply chains, which are the importers and the exporters, which we are not finding in this overview here at the moment, but they could be added for globalized supply chains. And what we have observed as well is quite a selection of secondary stakeholders, which we in most cases knew already from the literature. Interestingly, and this is a distinction between the 2 different visualizations, is that depending on the type of digital service or the digital technologies provided, you can find a different way of structuring. And we have distinguished and interpreted it in 2 different types of net chains. One is the digital net chain and the other one is the information net chain. And that depends on the type of technology and service offered. While the digital net chain consideration actually interprets that a solution is basically interfering or becoming part also of the primary net chain stakeholder core of that supply chain network. The information services is something that is offered to those actors in the so-called core from digital services from outside, and are potentially not interfering that much into the organizational structure in that core. For instance, if we are looking into the example, and we will see this in a second for the dairy supply chain network in the Netherlands. If, for instance, a dairy cooperative structure is created to store and distribute data, then this is becoming part of the structural DNA of the supply chain network. While, for instance, if solutions are offered that like a blockchain, then the solution can be outside and the information just used by the core actors. If we are looking into the results of the focus group discussions that we have conducted, and actually, okay. We have actually conducted in total 8 focus group discussions so far, but these are 5. We did 1 for fish in Spain, and 2 for dairy in the Netherlands, and 2 for dairy in Italy. With the difference to the expert interviews was that we have involved multiple stakeholders, primary and secondary stakeholders in those discussions. And they actually draw a bit of a more complex picture depending on the type of supply chain network we are looking into. And we also see that the primary and the secondary stakeholders differ by supply chain network. So those particularities, of course, need to be considered during the development of technologies, but also during the implementation of technologies, that different agri-food products may have different stakeholders involved. We also see that among the different products, there are differences in transparency issues that drive this whole supply chain network. While, for instance, and you can see that very well with the dairy ones. Dairy in the Netherlands is quite large scale and standardized production, while the one in Italy was specialized products on a smaller scale and a more regional production. You can see that the transparency interests in the dairy supply chain in the Netherlands are much more focused on efficiency and compliance with regulations, while the one in Italy was more on authenticity and quality and recognition of the value added to the products. Respectively, you can also find different gaps among the different supply chain networks. For instance, if you see that the transparency gaps in the dairy net chain of the Netherlands is on data ownership and control, then you can see that the transparency gaps of the smaller scale supply chain network is more on the data collection, digitization, and exchange. Summarizing and concluding, we can find actually quite a set of primary and secondary stakeholders in supply chain networks, and one of them is the primary ones are basically, in a nutshell, input providers, primary producers, processing, transportation, distribution, retail, and consumers, while consumers must be considered are no businesses, like the other ones. And I highlighted primary producers and retail because this has become very clear during the discussions that while the primary producers basically are the main controllers of information and data, and are with this also in the core of transparency interests and demands of later stages in the food supply chain, the retailers and the processors are basically driving the transparency interests also on behalf of the consumers. And this is where conflicting stakeholder interests can lead to hesitation to uptake solutions that increase the transparency if the primary stakeholders and those who basically have to provide the information don't see how they themselves can capture value from all this. They see the later stages capturing the value. What we as well observe is quite a lot of secondary stakeholders, government and policymakers, NGOs, certification and standard setters, regulators and control bodies, technology providers. Social media was highlighted even more than normal media, but also research institutes and universities to shed more light into what has to be done to increase the transparencies. Laboratories, support services, advisory service, and financial services were mentioned. Also here, the ones that were considered core by different stakeholders and technology providers have been highlighted in bold. What is the what actually comes out of the interviews as an observation as well is that traders and transport and logistics companies should receive more attention from digital technology providers, but also from researchers, because this is something that is far under-researched, and it turned out also during our data collection. And we see new secondary stakeholders that are emerging in EU food supply chain networks to provide digital transparency, and that they are getting actually quite unique and new roles in those systems. And what really should be considered is that they potentially need new different forms of collaborations and also governance to implement, for instance, also the collaboration with competitors and the open sharing of data without competitive disadvantages that businesses may face. Thank you very much for your attention, and I'm happy to answer your questions as far as I understood from Edward later.
Yes, thank you very much again for a very interesting presentation. We are keeping very well with time, but I would like now to give the floor to Joe Livingston from Northern Ireland to present his work.
Thanks, Edward. Just share my screen. Everyone see that okay?
Yes, that's very good.
Perfect. All right. Hi, so I'm Joe Livingston from Queen's University in Belfast. I'm part of work package 6, Pilots for Health. And my work's looking at developing this SUS Health Index and applying it to living labs. So just a quick bit of background. So transformative changes are required within the food system to optimize both societal and planetary health. And citizens as consumers play key roles as drivers of positive change, people like consumers, businesses, government, civil society. But oftentimes there's dual, sometimes conflicting messaging regarding nutrition, environment, and it's hard for consumers really to make up their mind on what the best choices are for things to eat. Industry also needs to know what good looks like in terms of transformative change and have confidence of future demand. So objectives, some of the objectives of SUS Health that I'll talk about today are to co-develop and demonstrate with stakeholders. So we develop with different industry leaders, restaurateurs, people from policy, and then other academics, a metric that was based on recent studies to describe how nutritious food is combined with its environmental impact. And then test this SUS Health score based in living labs, so basically in different restaurants involving co-production with consumers again and stakeholders in major quick service restaurants or canteens. Also do it on internet-based retailers as well in both the UK and the EU. So just looking at the creation of the SUS Health Index, so just outlining the system boundaries and some of the key outputs. So for the projects, a 3-year project, one of the main things that we had to decide at the start was basically just to use existing models for both the environmental and nutritional side of the index. We didn't have time to develop our own sort of nutritional model and our own environmental model. So I had to use things that are already being used in the literature. Pragmatic use of data. So again, we didn't have time to get primary data for all the different ingredients and things that we were going to assess. So we had to use data that was already available in different databases. For the environmental side, we took system boundaries of farm to shelf. So everything from the production of ingredients at the farm level up to where you either buy it in a supermarket or local distribution center for different restaurants. So we didn't include things for the environment side. We didn't include things like the cooking of the food or transporting it from the supermarket to your home or to the restaurant. And that was just because there's too much variance there really to try and capture that in any way. And then we also didn't include social issues, things like animal welfare, slavery, just again, because those weren't really quantifiable from the literature, and couldn't really add them to a suite of environmental impacts. So the key outputs is to produce a single score index using nutritional environmental metrics. The index should be transparent, applicable to meals and relevant to supply chains, appropriate for use in our living lab experiments. Avoid B, so we don't want all the scores to come out, to be C out of E. And then also to be consumer friendly, so that's to be easily understood by consumers. And we wanted them to be both objective and quantitative, so we could compare them across different meals and different restaurants and different supermarkets, but they also had a quantitative value that could allow you to see sort of the different nuances in the different scores. So for the environmental impact component, we looked at EnviroScore, which was developed by ASTI and Leuven. And this basically grades foods from A to E. So A, very low environmental impact, to E, very high environmental impact. And that's based on 13 different impact categories. So things like climate change, water use, resource usage, different types of eutrophication, acidification, things like that. And it's based on the product environmental footprint methodology. So then these 13 impact categories are normalized and weighted to give a single score, which is called the European Food Environmental Footprint Single Index, which is quite a mouthful, EFSI. And why we use this, it was recently published methodology, it's been validated, and it's applicable for the different databases that we had to use. So going from a recipe to your EnviroScore, so there's 5 sort of main steps. So the first one is to convert the ingredients in the recipe into kilograms. So obviously within restaurant recipes, you'll get things like cups or spoons, different things. So that will also be converted into kilograms. We ought to get the information on the sourcing of the food. So what country food came from, any sort of production information that they might have, and then try and find in the different databases ingredients that would match what the restaurant has told us. And then calculate the environmental impact for each ingredient up to the farm gate at that stage. Then calculate the impact for packaging requirements, the impact for transport requirements, and add that all together to get the environmental impact of 1 kilogram of each ingredient. And then multiply that by how much is required for the recipe and sum up all the different ingredients in the recipe to get the environmental impact per kilogram of meal and compare that to the different cutoffs. So quick example is linguine arrabbiata, which we used in one of our living labs. So there's different ingredients that go into it in the different quantities. So then this table basically just shows sort of some of the assumptions that need to be made when you're getting the environmental impact data for the different ingredients. So I would look in the database. So if the restaurant told me that they had red onions from Spain, for example, if you see the third ingredient down, I had to look in the different databases that we have to see, is there any environmental impact information for red onions from Spain? In this case, there wasn't. There was just impacts for onions grown in France. So I had to use that as an approximation for red onions grown in Spain, if that makes sense. So the different ingredients that are in red are the ones where there wasn't sort of an ingredient match. So like another one, garlic, I had to use onions again. Linguine, dry passes, essentially the same. And then anything in white was where I could get an ingredient match, but not a country of origin match. So for example, fennel, I could get production of fennel, but it was a global average rather than specific to France. And then in green is where it was able to match up both the ingredient and the country of origin. So chopped tomatoes produced in Italy, I was able to get that information. So then you add all that data in for each score plus the packaging and transport requirements, and you get the EFSI, the environmental impact per ingredient. Total that all up together and divide it by the quantity of food in the meal. And I guess this for the linguine arrabbiata, it was 8.45 times 10 to the minus 4. And so then you look at the EnviroScore cutoffs table, and you can see that that sits in the B range, so low environmental impact for that meal. So then looking at the nutritional side of things, so for this we use the Ofcom NPM, which is sort of the British policy for food labelling in the UK, and we also sort of combined it with Nutri-Score cutoffs. So in this case, to calculate the nutritional value of the meal, there's sort of 3 different options. So if the food, you have these A points and C points. So the A points are kind of the bad things like saturated fat, sugar, salt. The C points are the good things like fruit, veg, nuts, fiber, protein. So if you've got less than 11 A points, then you take away C points, including fruit, veg, nuts, fiber, and protein. If you've got more than 11 A points, but also more than 5 fruit and veg points, then again, it's the same equation. But if you have more than 11 A points and less than 5 points for fruit, veg, and nuts, then you drop protein from the C points. And anything that has a score greater or more that's a food is classified as less healthy. If it's less than 4, it's classified as more healthy. Anything that's 1 or more for a drink is classified as less healthy. So from recipe to the NPM, again, convert quantities into grams. Then for the nutritional side of things, you had to look at by cooking. So look at the quantities after cooking for each of the ingredients. Then find the quantities of nutrients per portion, then per 100 grams of meal, and then estimate the score. So again, this is just the point system. So you've got points not 1 to 10 for the A's and 0 to 5 for the C's. And then from your meal, say if you knew that you had 671 kilocalories, you go down that second column to 670 and see that that would be 2 points for energy. So for the linguine arrabbiata, we had 729 kilocalories or kilojoules of energy, so I got 2 points. Saturated fat was 0 points, total sugar was 2 points, so that gave us total A points of 4. Then for fruit, veg, and nuts, it was another 2 points, 3 points for fiber, 3 points for protein. So you take your 4, take away 8, and that gets you a score of -4, so which would be a more healthy meal. The lowest score you can get is -15, the highest score is 40. So then we had to combine the 2 sides of the index, so combining the Enviro score, the FSI with the NPM. So to do this, we use composite indicator method. So this is formed when individual indicators are compiled into a single index on the basis of an underlying model of the multi-dimensional concept that's being measured. And the advantage of this technique is that we could compare the meals with meals from other menus. So another option was to use something like a nutritional LCA, but then you could only really rank the different meals in the same menu that we'd used. So that's why we used the composite indicator method, so we could get sort of objective and quantifiable results. So the steps in this: estimate the environmental score, estimate the nutrient score, and then normalize the score. So we use just a pretty common normalization method, which is this x minus x min equal divided by x max minus x min. So that just normalizes the 2 different scales that you have. So the FSI's got a totally different scale, obviously, to the NPM. To normalize them to get both scales would be then between 0 and 1. And then aggregating the individual scores. So in this case, this is where you sort of pick the weighting. So what's the most important, the nutrition or the environmental side? We just went for an average, so both equal weights. So 0.5 times the normalized NPM plus 0.5 times the FSI. So just looking at an example of how this is calculated again for our linguine arrabbiata. So for the NPM, the score was -4. So to normalize that, you take away the minimum score, which is -15, divide it by the max, which is 40, minus -15 again, and it gets 0.2. And then for the FSI, the same thing. So the minimum for that was 0. The maximum was 0.013. It's sort of a theoretical maximum that we took. And you get 0.07. So you add those together, divide by 2, and the overall combined score is 0.13. And then if you want to make it maybe more consumer friendly, you can change that into like a percentage. So you can change it, and it would be 87% for that score. So then how to decide what was, a good score and a bad score? We had to create bands, which is when we sort of looked at Nutri-Score rather than NPM. NPM sort of more of a binary result, so it just tells you whether it's less healthy or more healthy, whereas the Nutri-Score is the same as Enviro score in that it has an A to E scale. So anything less than -1 was an A, anything greater than 19 was an E. So then essentially the same equation just to normalize the A to E scores. So it would be 0.03 plus 0.255 divided by 2 for the A scores. That's where your 0.14 comes from. And the same for each of the different bands. And then you can adjust that scale. So anything over 86% was an A, anything below 31% was an E. Yeah, so some of the assumptions then, so different assumptions that we had to make. Packaging type and amounts for the different ingredients just based on sort of the standards used in the databases. So it was quite difficult getting even basic recipe information out of the restaurants at times. So sort of had to cut it off at a certain level so we didn't try ask them about their different packagings. Transport distances, again, they sort of only told us really country of origin, not exactly where in the country the foods came from. So for example, onions from Spain, I would just look up where are most onions exported from Spain, and then work out the distances from that. Mode of transport, again, is just based on sort of the standards used in the databases. So if the database said standard transport for onions was in like a refrigerated lorry, then that's what I would use. Production method, if we weren't told by the restaurant, we just assumed based on the most common method. And then in terms of the nutritional side of things like the method of cooking, so was it slow cooked, was it shallow fried, whatever, just as had to be assumed at times, and even how long the food was cooked for. And then smaller things like cooking oil quantities, so it's hard to know, if it was battered fish and it was deep fried, how much oil was actually incorporated. That was sort of worked out by the different software that we had. So then limitations, so different data sources can have a big effect on the results. So sometimes you could get 2 different data sources for the same ingredient in the same place. So say it was chicken from France, you could have one database, say Gribouillies, that had a different score to another database, say Agri Footprint, that could have quite a big effect on the results. And really, it's just up to me to decide which database to use. So if you wanted to make your scores as good as possible, obviously you'd use the better scores. And if you want to make it look as bad as possible, you'd use the worst scores. So that's one of the limitations, really, is just there's an arbitrary choice there, really, of what database to use. As I said, we've had to use pragmatic data, so no primary data, so it's not real world supply chain specific. So even if you are getting an ingredient, so say the chopped tomatoes from Italy, even different factories in Italy might produce their chopped tomatoes in different ways. So some might be more environmentally friendly than others, but we are just taking averages there. Enviro scores sort of designed more for individual food items, individual ingredients. So it's quite hard to get extremes of A to E for full meals. So because you've got like a mix of different ingredients, they sort of tend to average it out. So it's quite hard to get those A's and E's, but you can get the B's to D's quite easily. Again, as I said, it doesn't include impacts like biodiversity, which is quite hard to quantify, or non-environmental issues like human slavery or animal welfare. The nutritional side uses the NPM to calculate the score, but takes the cutoff from Nutri-Score, which is slightly different to NPM, even though it's sort of based on the same thing. And then in terms of combining the 2 scores, we're sort of combining 2 different cutoffs from 2 different indices that were made using different procedures, different food samples into one. So statistically, there might be some issues there. So yeah, those are the main limitations. So then just the design of the index, this is what we've come up with, sort of like a wee donut, where you've got your environmental score on the top, nutritional score on the bottom, and then everything's color coded. So we're looking at changing the wording there from very good to very bad. I'm going to put something else in, but that's just what we have at the minute. So dark green, very good score, red, very bad score, and then you've got the 3 different aspects that are color coded. So the combined score in the middle with the letter. And then this is sort of what it looked like on a recipe or on a menu that we used in our living lab. So we've got the different meals and their descriptions, and then the SUS Health Index beside it, which I think are quite easy to work out what's going on. So we've done a couple of living labs now. We did the first pilot living lab just in a cafe at Queen's called Junction. We've now got ethics approval for all UK and EU living labs going forward. At the Junction one, it was quite a small pilot. There's only 8 participants. 1 vegetarian, 7 non-vegetarians. They had their initial choices were quite sustainable and healthy to begin with. And then we sort of gave out tokens for 5 salad bowls and 3 chipotle chicken salad bowls. 2 of the subjects changed their choices in response to Sus Health Index information. So basically we presented them with a normal menu where they made a choice, and then we presented them with a menu with the Sus Health Index information, and then they could change their choice if they wanted to. And then a third menu where the prices were adjusted depending on the scores. For this case, we had 25% of the people changing in response to Sus Health information. And then we've also completed a full UK Living Lab with 111 participants. And from that, we had roughly about 30% of people changing their scores based on the Sus Health information. And I think by the end of the third menu, 78% of people were choosing sort of A or B meals, compared to 50% from the base menu. So future living labs. So hopefully we're going to do at least 2 EU living labs. So we're in progress with Helsinki and Asti to host a couple of living labs, and then we've also been discussing with Delft University as well. And anywhere else, if there's anyone who's interested in hosting one of these, let me know. Yeah, we'll provide at the consortium meeting. I think we'll go into that in a bit more detail about what happens at the living labs as well. But that's everything.
Okay, thank you very much, Joe. Again, really interesting. So we've had now 3 really nice presentations, and they are open for questions. And I could see in the chat there was one question from let me see, Abdul Keri. I don't know if he is still in, and if you want to further explain your question. I don't know if he is allowed to, if he can be unmuted.
Just 1 second, please. Now he can talk.
Yeah, now you have to unmute
Wow.
yourself.
No,
Yeah.
he can't. Sorry.
Thank you. That's so great. I was waiting for this. Great. And honestly, that was something very exciting speech. And the science is explaining itself like the applicable level. So Martha already answered my question, but I am still digging the AI assisted food. Yeah, what was that? Ingredient and allergens detection. So this is something very interesting to me, because mainly the reason is that we see we could actually detect the fraud by using the DNA. So that I was thinking, okay, how could we? The main problem with olive oil, to my understanding, is that fraud with a different oil, like sunflower oil, things like that, right? Then because I use some part of olive oil in my production, then the major thing that is also my concern: how do we make sure that the olive oil what we receive is fully olive oil? For that, we do some HPLC and GCMS to profile the fatty acids, but this is something beyond that. So yes, that's something that was something great. So Martha really answered my questions, but I'm still learning more about this AI influence in the analysis. Great, thank you.
If you want to add something, Martha, please go ahead.
Yes, thanks a lot for the kind comments. And related with, I think you mentioned as well the allergen detection.
Right.
And well, the approach is similar to the olive oil. We don't detect the allergen itself because it's normally a protein. We detect the presence of the ingredient that might have this allergenic protein, right? Because we are working with DNA, but we know that, for example, if we can detect traces of sesame, it's because sesame is present, of course. So the allergen is as well present most likely. And then the combination with AI is we are doing this with other partner in Titan project, this AI Talentum. And I cannot give you all the details because it's not our specific word, but they are trying to develop an algorithm in order to predict the possible presence of allergens. So that will help the industry in order to do not have traces of the allergen in their products, and also help us with the analysis in order to know when will be advisable to analyze, how often, and these type of things. Okay.
Yes, great, thank you. That means you're going to have some kind of a database, something like that. Yeah.
I believe it will be like an algorithm that they are producing that, of course, is a pilot, so it will be quite specific to with the company that we are collaborating with, but I think it will be possible to transfer to other, industries, because they most likely have the same type of products. Okay.
Yes, it's an industrial challenge. Thank you.
Yes. Thanks a lot.
Okay, thank you very much. Now I see that Sarah is waving. Maybe she has a question.
Yes, thank you very much. So first of all, thank you for all the presentations, very interesting. I'm Sara La Monaca from Food Drink Europe. I have a question about the Enviro score. I wanted to ask what is the scope of application? Is it only for out of home, or also for prepackaged food, and if it has been tested for prepackaged food as well? Thank you.
Yeah, I think you can apply it really to anywhere sort of down the food supply chain. So prepackaged food as well should be all right. I'm not an expert on the Enviroscore. We just sort of used it because it was quite new and it looked good and it matched up well with Nutri-Score. But it seems to me you could apply it really to any sort of level on the supply chain. I think they actually, in the paper, they do from cradle to grave, really. So they even disposal of waste and things like that.
Yeah, maybe the
Okay,
question.
thank you.
Yeah, okay. Yeah, maybe the question relates to your living labs, because I think you mainly test your score, the Sus Health Index, in like a restaurant setting, in more food service. But to partly also answer the question of Sarah, on the 19th of June, people from ASTI will explain Enviro Digital, which is based on the Enviro score. So maybe you can also ask some questions in that webinar. Are there any other questions from the audience? Otherwise, I have a question for Verena. You explained in your presentation that you work with the definition from Hofstede, from that paper. Are you aware of other definitions for transparency, or do you think that the word transparency is always used in the way it's as defined by Hofstede?
Oh, these are basically two questions.
Yes.
The first one, of course, there are more definitions. The one by Hofstede has the advantage that it is quite detailed. It is not only on a single company level or a supply chain level, but it is on a supply chain network level, which explicitly includes also transparency to secondary stakeholders. And third, it's quite detailed about the type of transparency gaps that can occur. And I still remember when we discussed in the project development how do we define transparency. I remember that the technology providers were able to confirm that this is also a definition that you can adopt from other disciplines. So from the perspective of other disciplines, and we are an interdisciplinary project. So this is why it best fitted our research. But I have been reading quite a lot, of course, also on that topic. And often researchers also adopt a more broader and a bit more vague definition that, for instance, focuses only on, or makes a very general statement on its the amount of, or the way information is shared. And if information is shared, it's transparent. But you can, for instance, also have big data issues with too much information shared. So we found this one appropriately specific and interdisciplinary and fitting the research in for also work package 2. And the second question that you ask is about, is it always implemented like this? You see a lot in the literature that transparency by definition is used, for instance, synonymously to traceability, or it's a lot of overlapping. With regards to Hofstede, he defines that only as one possibility of one aspect of transparency, namely the history transparency. But transparency goes beyond traceability by including also information on operations, so to have a smooth flow of product across different stages, or information, or even strategy transparency on innovations that you want to develop and implement, or product portfolios that you want to change, which is of course highly sensitive and can also give you a disadvantage, competitive disadvantages if other stakeholders know about it. So yeah, the literature overall is not, let's say, following one unique definition stringently.
Okay, thank you, Val. Which makes it maybe challenging to write about the topic.
Always.
But, yeah, we can see. Okay, thank you very much. Then I have a question for Marta. You described your work, and then you showed 2 pictures of, let's say, schematic representation of a miniature device. Question is, are you working with companies that could build these devices for you, or that could build them and sell them to their customers?
Not yet, let's say, because we want to have a good prototype first that we could then try to investigate the scalability of the product with different companies, right? So we want to have a better idea of the best design as such before starting to work on the scalability, but it's something that of course it will be very, very interesting. Yes.
Yeah, you could think, well, they need to know in time which direction you are going, so that they also maybe can start designing. But it's totally up to you. Yeah. Okay, thank you. Then I have a question for Joe. I was thinking maybe it would also be a possibility, but at the time I was thinking about this, you hadn't shown the donut yet, to just give the lowest score of the 2. So you more or less calculate the Nutri-score, you more or less calculate the Enviro score, and then the total could be the lowest one of the 2. Is that an option that you have considered?
No, it's not. We don't think we've ever considered that, but I'll pass that by to the rest of the team. Something different to think about.
Yeah, you have performed tests already, and I think what I liked is that you showed both scores, and then you showed the SUS health index. So it gives insight to people on the health and the environmental impact. So I think in that sense it's quite good.
Yeah.
And then I would think that the number of people that changed their mind is quite high. Can you give some comments on that?
Yeah. So we sort of thought if people are going out to a restaurant or something, they might not really change their minds based on the scores. You sort of know what you want to eat when you're going out. But then when they're there, people weren't really sure what they wanted. So then if they got the scores, if they're choosing between 2, they might switch to the one that had the better score. That makes sense. So we find quite a lot. I think it was about 30% of people changed between the first 2 menus out of 111. And again, those are people that are sort of maybe undecided. And then quite a lot of people had already picked maybe the best score anyway. So
did they know the score with their first choice already?
No, that was before they knew the score.
Yeah.
So the first menu is just sort of a plain menu, just like a normal menu you get in a restaurant. So they would have picked whatever they wanted off that. And then the second menu they picked again, but it had the SUS health information. So at that stage, maybe about 30% of people changed to something that had a better score. And then on the third menu, we had some price adjustments. So the scores, so the A and B scores, their prices were reduced, and the C and D scores were left the same. And then at the end, they sort of rolled a dice to decide which choice they would get from menu card 1, 2, or 3. So there's an even chance that they would have to eat the meal from each of the different menu cards, and then they got the meal afterwards.
Okay. Well, I would think when 30% of the customers, let's say, changes their purchase decision based on the score, I think that for me that would make it quite effective.
Yeah.
So
we were pretty pleased with
Yeah.
the results. It was quite a big change.
Yeah. And then I have another question, which is about more the production of the products. Maybe you know the organization Carbon Cloud. They also have a database about the environmental impact of food products.
Okay. Yeah.
And then when you look at tomatoes, they can say, well, you can get tomatoes from the UK or from the Netherlands or France or Spain, but they are produced under different conditions. Like in the UK and the Netherlands, they would be produced in glass houses where they use gas. So the environmental impact would be much higher. But of course, the distance would be much smaller. And then in France or Spain, it will be just outside. And can you take this into account, these differences?
Yes. Sometimes it depends if the data is there. There is normally data for stuff like in greenhouse or open field and things like that. I think the best option normally is an unheated greenhouse. Seems to have the lowest environmental impact compared to an open field. Uses maybe quite a lot more water and land use, and then your greenhouse obviously uses more energy if you're heating it. But yeah, you can. It just depends on the different ingredients. So some ingredients you can make that definite distinction, and sometimes you can't.
Yeah. Okay. Thank you.
No worries.
Then I have one question for Verena, which relates to the remark you made about if let's say a technology provider becomes part of the network or not, if they stayed outside or not, and what happens with the data if the data will be part of the network or of the provider. I think that's a very interesting aspect. So maybe you can tell a little bit more about it.
That indeed depends on the organizational structure and the governance. So which agreements have been made about data ownership? I mean, also the ownership of data also relates to who has the power, or it changes power relationships in the supply chain network. The example that we were thinking of is, for instance, if typical for the dairy sector is that product cooperatives exist. So cooperatives to process the dairy product. What we now see, for instance, as an example, is that also organizations are forming from supply chain network stakeholders to form data warehousing or data handling organizations or cooperatives with shared ownership. And they are, of course, then having still the ownership over the data, while if it's an external company you're supplying your data to, the ownership of the data is potentially leaving their control. But that depends, of course, on terms and conditions and the way you institutionalize that.
Yeah, because I think there's an example from the US, from a large retail chain, that they have given the ownership of the data to the let's say the technology provider to make it easier in that sense. But I can imagine indeed that the cooperative is much more reluctant to do this.
Yeah, and the thing is also that potentially those who are supposed to supply the data will be relatively reluctant to do that, because they see that they are losing the ownership and they will not be able to capture the value that is finally captured by later stages. So they are not having any shares there anymore. And if you see, this is the effect or the relationship that I try to explain, is that a lot of demands are put on the earlier stages, so the farmers, for instance, the primary producers, with regards to providing and supplying all this information and data. But when the ownership is handed over as well, then they will not take part of capturing the value from it.
Yeah, I think that's what you mentioned in your presentation. They will not benefit from it. So
Yeah.
in that sense, maybe they are more reluctant to participate even.
And this is why we are looking later in the work package too into well-fitting organizational structures to these new roles and interests, because that will have a huge influence on what the overall transparency of the food supply chain network is, how interests are considered in such structures, and how the relationships are governed.
Yes, indeed. Thank you very much. I don't know from all the people in the audience if there are any questions. Still now you have time to ask a question if you have one. Otherwise, you can always try to reach us. Yes, there's someone waving. Let me see. Or not. I thought I saw someone. I would like to thank you very much for listening in. First, I would like to thank the presenters for excellent presentations. Would like to thank you for your attention. And then please check out the Titan project. Go to the website, go to the LinkedIn page, check our Titan Weekly, check our newsletter. And please join us again on the 19th of June for our upcoming webinar. And thank you all very much and have a nice afternoon.